So today we're going to cover Chapter 6, Section 5. The other trigonometric functions that we're going to graph today are going to be the reciprocal functions of sine and cosine. So we're going to be graphing cosecant and secant today. So this is what the graph of the cosecant graph looks like. Remember, we're more familiar with seeing cosecant as CSC. So what's going to happen is, if you zoom into the picture here, the dashed line is the sine graph. So you're going to have to first graph the sine graph. Then what you're going to do is every spot that your sine graph touches the x-axis, at every one of these points, you're going to be drawing in a vertical asymptote. So I have vertical asymptotes at every spot that my sine graph here has touched the x-axis. And then at each one of the maximum and minimum points of my sine graph, so right here is a maximum, a minimum, a maximum, a minimum, and then you're going to use the asymptotes as guides, and then you're going to draw in parabola shapes from the maximum, using the asymptotes as the guide, same from the minimums. And the blue is the final cosecant graph. So you will first graph it. Now you'll be able to do it in color. So if you want to give me like a key when you're doing your work and say that the final graph is in blue. However, when you're doing this on the test, you will be doing all of these graphs by hand. It will not be multiple choice. So if you want to maybe either do the sine or the cosine graph in dashed lines like this is done, and then the final graph as solid lines, you can do that. If you want colored pencils, I do have them. I can bring them out when we go to test on this. But when you're doing it, Notability, you can change the color and then just tell me the color of your final graph. Now, let me show you what this means to us and why we have asymptotes at those coordinates. So, for example, if you think about the coordinate plane here, and when we have our 0 and 2 pi, we have our pi over 2, we have our pi, and then the 3 pi over 2. And then remember the coordinates we're using for all of these quadrant angles. This would be the order pair 1, 0. This would be 0, 1. Over here, -1, 0. And then finally 0, -1. So for example, if I wanted to do sine of pi, remember sine looks at the y of the order pair, or again you could think of it as y over r, but remember when we use these first order pairs, the r value is always 1, and I know that sine's going to look at y, so it's 0 over 1. I'm using the order pair, -1, 0. And then this simplifies to 0. But then if I do cosecant, the reciprocal of pi, and you flip this, then it becomes 1 over 0, which is undefined. So if you come over here and you look at the graph now, and I look to see where pi is, here is my order pair for pi. It's the order pair pi, 0. And notice if I were to try to graph for cosecant, this is where it's undefined, and this is why there's an asymptote right here. Because when I do cosecant of pi, it's undefined, and there is no point there for the cosecant graph. So every place that my sine graph touches the x-axis, when the sine value is 0, the cosecant is going to be undefined. And that's why there is an asymptote there. So for the graph of the secant graph, again, same thing. We're going to realize that secant, its reciprocal is cosine. So the dashed line is a graph of the cosine graph. So if I zoom in here, remember cosine always starts at 1 unless there's an amplitude, and then it goes down, and then it goes down a little bit more, and here, and then finally completing the cycle. So you can do the pattern here. Now, just like the cosecant graph, every spot that my graph touches the x-axis, this is where I have an asymptote. And then once you've graphed the cosine graph, then what you can do is find all the maximum and minimum points, and then you'll draw in your parabolas. Now, what I like to do for these graphs, and I didn't show you that on the cosecant graph, but the normal cycle is going to be just like the sine and the cosine graph, 2 pi. So what I'm going to do is I'm going to box it in. Pretend like this is the viewing screen on your calculator. So I'm going to box this in. And really all I want to see graphed is 2 complete cycles. And notice over here, this should have also had like another U shape, but it's out of my viewing, so I don't need to show that. So that's at this maximum, and then at this minimum, you make your parabola, use the asymptotes as a guide. I got another maximum here, so another parabola shape. Same here. And then over here, it's just not complete because it's out of my viewing window. So I don't need to show those pieces that go outside of the cycle. So when we go to graph the cosecant and the secant, we're going to first graph for cosecant. We're going to graph the sine graph, and then add in the asymptotes, and then add in your parabola shapes. And then for the secant, we'll graph the cosine graph first, and then add in the asymptotes, and then graph the parabolas at the max and the mins. So here's my first example. So the 2, remember, when there's a number in front, this is your amplitude. Now this 1/2 here, this is going to be my b value. So I need to, the normal cycle for sine, cosine, secant, and cosecant is going to be 2 pi. So remember, you take 2 pi, divide it by b. So I'm going to do 2 pi divided by 1/2. So when I divide, keep, change, flip, it's really 2 pi over 1 times 2 over 1, and I get 4 pi. I'm going to do the calculations exactly the same thing, because what we're really going to graph first is going to be y equals 2 cosine 1/2 x. So the calculations are still the same for the x key points. So I'm going to graph this first. But let me get my key points for my x-axis. So I take 4 pi, multiply it by 1/4, 4 pi times 1/2, 4 pi times 3/4, and then 4 pi 4 over 4, which is just 4 pi. Go ahead and multiply these. So this simplifies diagonally. The 4s would cancel out and become 1s. So this is just pi. And then this one would become 4 pi over 2, which is 2 pi. This becomes 3 pi. So now we're going to graph the cosine graph first, and then we're going to add in the asymptotes, and then at each max and min, we're going to add in the parabola shapes. So let me go ahead and set this up. So I'm going to put my key points along the x-axis. So I have pi, 2 pi, 3 pi, 4 pi. And again, it's like a reflection when there's not a phase shift. So negative 2 pi, negative 3 pi, negative 4 pi. And then you're just going to add in the amplitude. So I could put a 2 here and a negative 2 here. So now what we're going to do is we're going to graph the cosine graph first. So I'm going to graph that one in blue, and then I'll do my final one in red, I guess. So let's do it in blue first. So remember, the cosine graph normally would start at 1, but it's got an amplitude, so I start at the amplitude. So I'm going to start at 2, then I'm going to go down to pi, then down again to at the 2 pi, and then back up, and then back up again. So I can add my little bends here, and then now complete the cycle on the left side. So down, down, up, up. So again, on the test, you could do this as a broken line to distinguish. Now, I'm going to go ahead and box this in. I only want to see your graph for the secant graph in this viewing area. I don't need to see any more than that. Okay, so now every spot that my graph touches the x-axis, that's where I have asymptotes. So I've got an asymptote right here. I've also got one here at the out of the viewing area. No, I don't. All right, so here, here, and here. Those are my asymptotes. So now at each max and min, so I got a maximum right here. Let me do maybe purple, because I'll do it in purple so it shows up better since I've got the red background. All right, so here at this maximum, if you wanted to, if it helps you to see the parabola better, but I don't need to see this branch of it. And then down here at this minimum, use the asymptotes as guides. And then up here at this maximum, use the asymptotes as guides. And then down. And then finally over here, because this one's outside the viewing area, we don't need to see that. So my final graph is in purple. On the test, I will want to see the asymptotes, and I want to see the key points on both the x-axis and the y-axis. And then I'll want to see those parabola shapes. So what we're going to do here is we need to first graph y equals negative sine and then x minus pi. Now, for both the secant, the cosecant, and the sine, the x key points, the ones along the x-axis, are going to be the same. So also, this negative sign that's in front, we can assume it's a -1, and that's my amplitude. And then the minus pi here, this is backwards of what you think. I'm shifting my graph to the right over to pi. So really, I'm starting at positive pi. All right, so now let's do the calculations. So this time I don't find 1/4, 1/2, 3/4. When it's a phase shift, you take the starting point, which in this case is pi, and we need to add pi over 2. So I need to find a common denominator. My common denominator is going to be 2. So I'm actually going to change the pi and make it 2 pi over 2. And then now I can add the pi over 2. So I'm starting at pi. I need to find 4 points to the right, 4 points to the left. So once I do this first calculation, this gives me my first point to the right. I'm going to take that, add another pi over 2, and I get 4 pi over 2, which will simplify to 2 pi. And then I'm going to take the unsimplified, because I'd have to go back and find a common denominator anyways, 5 pi over 2, and I need to do it one more time. 5 pi over 2 plus pi over 2 is 6 pi over 2, which equals 3 pi. So these are going to be my 4 key points to the right of pi, which is where I'm starting. Now I need to do exactly the same thing, but subtract pi over 2. So I'm doing pi, my starting point, minus pi over 2. So once I do this, common denominator, so I'm really just changing this into 2 pi over 2. Now, notice when I do this first calculation, I'm not getting a negative number, but pi over 2 is to the left of pi. It's 90 degrees apart. If you think about it, pi is 180. Pi over 2 is 90. So they're still 90 degrees apart. So in the homework last night, somebody came this morning and asked about it. Why didn't I get a negative answer? It's because this is where it's ending up. It's still to the left of my starting point, and it just happens to be a positive coordinate, and that's okay. Depends on how far you're shifting it. So now, when I take it again, the pi over 2, subtract pi over 2, notice my next point is 0. Remember, yesterday I told you there's not always going to be a stopping point on the y-axis. This one has one. A lot of times when your shift is pi over 4 or pi over 2, or even pi, you would have a stopping point on the y-axis, but not always. So then now do it one more time. Negative pi over 2. And then I need 3, so I got to do it again. And I get negative 2 pi over 2, which simplifies to negative pi. Okay, so let me go ahead and... So x and y axis here. I'm going to add in these 9 points. So I've got my starting point, which was pi. Actually, I got pi over 2. Then pi. Then 3 pi over 2. Then 2 pi. Then 5 pi over 2. And then 3 pi. And then in the other direction, negative pi over 2. And then negative pi. So it sort of looks lopsided. But remember, this is where we started. So my 4 points onto the left side are going to be the pi over 2, the 0, the negative pi over 2, and the negative pi. And then these are the 4 points to the right side of the start. So it looks lopsided, but again, it's just 4 key points to the left side and to the right side. It doesn't necessarily have to be 4 on the other side of the y-axis. Everybody understand what I'm saying? Okay. Okay, so pi is my starting point. Again, I have to graph the sine graph first. Let me add in my amplitude. So it's a -1. All that -1 is going to tell me is I go down to -1 first. Because remember, sine normally starts at 0, 0. However, we're starting at pi on the 0. So we're actually starting right here. And then from there, going down to the amplitude, which is the -1, and then back up, and then up here, and then back down again. I'm going to go ahead and I can add my little bends in, and then complete the cycle that's to the left of the starting point. So at pi over 2, I'm now up here. And this one has a stopping point on 0. So down here, and then back to the same level. Notice I started on the x-axis at pi, and I ended my cycle on the x-axis. So let's add in our little viewing window here. Yeah. Okay, so this is my viewing window here, where I want to see your graph. And again, let's add in the asymptotes. So at every place that my sine graph touches the x-axis, I'm going to put in asymptote. So I have one here, 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 and here. And now at each maximum and minimum point, I'm going to add in my parabolas. So down here at this minimum, parabola. Up here at the max, parabola. Using the asymptotes as a guide. Same thing here. And same thing up here. So you have to graph the sine graph when it's cosecant. And then from there, add in your asymptotes. And then add in your parabolas.